Hi, everyone. Welcome to the BP Launchpad session on the software and energy transition. I'm excited to be here and especially have the honor of kicking off the session. I'm actually in my ninth week at BP. It's been a lot of fun ramping up on a new space, a new company. And in my new role at BP as the VP of Digital Engineering, I actually get to be at the center of BP's transition towards being a software and technology company, which I think is a big part of the panel discussion today. A lot of people have asked me over the last couple months, sort of how BP is going to transition to being more of a software company, and you know this is basically the first time I've had to transition a company in this direction. I've traditionally come from software companies like Microsoft and Amazon that are already operating in that mode. And ultimately, I think the core of our transition is really around people. And it really starts with hiring the right people, taking the existing BP employees who are excited by this space and helping them grow into more of these software roles. So I've actually spent the last 2 months really focused on what does it mean to be a software engineer at BP? What does good look like from a people and development perspective? But then also, what are all the things we need to do to enable software engineers to be productive at BP and build the right solutions? And ultimately, what does good look like at the end after we've delivered what we need to deliver? So it's a super exciting space. And it's been really interesting to sort of see the journey BP's been on and then help accelerate it in new and interesting directions. Like I said, my background is predominantly at Amazon and Microsoft, where sort of the culture and how we operate has already been embedded. And so reverse engineering that and sort of creating that at BP at scale is a super interesting challenge. And as I look across sort of BP, talk to external candidates about joining us on this journey, it's been really nice to see how excited everyone is about the different challenges, right? Software engineers don't always get the opportunity to work on such a diverse set of problems at global scale that both are in the digital world, right? Services, microservices, things like that, but then also touch the physical, right? Production rigs with IoT devices and how we operate those in a safe manner, how we operate them efficiently while also reducing cost over time. The sort of variety of challenges that exist here really don't exist in many places in the world, or at least don't exist at the scale we have. So that's been particularly interesting. The other, I think, sort of novel opportunity of BP as part of this transition is how many of the core systems that might exist in software companies today where we have not yet had the chance to build them. So a lot of engineers I talk to are very excited about the chance to come in and just for example, create a logging and telemetry platform. It's something you take for granted if you're already in a big tech company. At BP, we have lots of fragmentation just over time because the different businesses have started and matured at different ways. And so the opportunity to create some of these core platforms, solve some of these core challenges is super exciting to a lot of software engineers. So I continue to be energized and excited about my role. I know it's going to be a multi-year journey. We're not going to flip the switch overnight and be operating like a tech company. However, I think we have a lot of the right bones to get there. Right, the problems are interesting and real. We have the resources to make the transition, and there's a lot of energy externally where folks want to find meaningful problems to work on, and they're drawn to companies like BP that are being pretty vocal about that transition. So that's just a little bit about my role and opportunity. Some of the things I'll be working on over the next couple years, but really sort of in earnest over the next couple months, rolling out things like what are the role expectations for software engineers? How do we want to hire? How do we make software engineers successful when they're here or when they start? So things like boot camps. Are we providing the right tooling? Are we pulsing the community to understand their pain points and helping improve? And then ultimately, what are the standards by which we want to deliver against from a technical operational standpoint? Where do we decide to consolidate and versus where do we allow invention and good variability in what we deliver? So those would be a lot of the things I'm focused on. We'll be launching a bunch of new information out into the community sort of beginning of next year. Excited to see how people respond to that. We're also exploring ways for individuals who maybe don't come from a tech background. How do they get into a software role, for example, by sponsoring boot camps, other educational and growth opportunities. So stay tuned for more info for anyone who's curious about those. And I will also be available later in the session if there's any particular questions about the transition, things we're looking to offer, or different opportunities, within my world. With that, I'm excited to welcome everyone, and I want to introduce my colleague other Ed, to take us forward from here.
Hello, and thank you all for joining, and thank you, Ed, for that great intro there. So for those that don't know or have not seen you before, my name is Ed Strickland, engineering expert here at BP Launchpad, and we're joined today by, I'm just waiting for other Ed to come back in. There he is, or at least there's a round all that for him. And we're joined today by Habiba and by Mike, and also by other Ed as, technical difficulties, problems in the studio. So Ed Banty will join us again shortly. So I guess to kick off, maybe Habiba, would you like to give an introduction to yourself, and then I'll come to Mike in a second.
So hi guys, my name is Dr. Habiba Lais. I'm a technologist at Tribosonics. So Tribosonics, we're based in Sheffield in the UK, and we're a high-tech scale-up where we are trying to connect the physical world to the digital world using ultrasonic sensing technology.
Cool. And I'm Michael Tempest. I'm a technology director at Critical Mass, where we're a customer experience agency, and we spread across the whole scale of things from creative through to technology. So we can do UX, UI. We work across production, so 3D production, and then from a technology aspect, we can do the whole realm of digital, and I kind of look after things from a technology perspective across London and Tokyo.
Brilliant. And effectively, Ed's already given his introduction. He's still having some technical issues with his video. We're hoping he's going to join us very shortly. We will keep an eye out for that. He will definitely be back for the Q&A at the end here, even if he's not able to join us now. We've got a few sort of questions that we've sort of loaded into this, and I'm just bringing those questions up now. There he is. Hey. Always fun with technology, isn't it? My word has decided to.
I think there was a rule: only one Ed on screen at a time. So I think that's
so that people aren't confused by any of this. So I think fundamentally we're talking about the issues that are sort of faced with scaling tech companies and moving them forward. So I was wondering if maybe Mike, you might like to start the discussion off. I'm still trying to get this, as is always the way. Never trust a PDF. Come on, Acrobat. Thank you. Mike, sorry, the first question is there a specific, I guess, and we'll ask the whole panel this really, is there a specific talent, I guess, technology experts or engineers or AI, machine learning experts from any part of the industry sort of would really need to have expertise in the energy industry as well. Do you think there are parallels between the two? Do you think that they one can be learned? So can you learn about energy industry when you're already a technology expert? I guess Ed Banty might have a few thoughts on that from the point of view of he's been here for about 9 weeks now. But do you think that really you can learn the industry that you walk into from a technology point of view?
Yeah, so it's an interesting question, because a lot of people feel like in any industry that industry knowledge is actually paramount to the role, when actually it's more about how the organization, for me, is set up. Obviously, there's nuances of knowledge that people need to understand in different industries, and energy's the same. So for me, it's kind of, are you structured right that you have that expertise in-house, but also structured right that it can be kind of relayed to all of your staff, so that from your staff's understanding, they can help with those decisions and kind of build towards those goals collectively. So it's, for me, it's definitely more of a process and positions in place that you have the experience in-house, but I don't think the technology team necessarily has to have that expertise, unless it's like hardware specific challenges. You know, if we're hooking into hardware, then yeah, that's a different matter, because you have to know the nuances of the hardware to be able to make the software for it. But yeah, I'd say it can all be learned. I think from a technology perspective, it's all about, at the end of the day, you're building for someone and something, and there's obviously a business goal attached to that. As long as you can marry that all up as a team, and then yeah, you can do anything really.
That's a very positive spin. Habiba, would you share that opinion? You're coming from a slightly different angle, being effectively not a software engineer.
No, so I'm on the ultrasonic side. So I would say when it comes to working with ultrasounds, that you end up putting that technology into so many different sectors that it's hard for you to learn about a particular energy sector and then keep that and then use that to keep reapplying your technology onto. So I guess the main thing is to make sure that you're good at your expertise, and you know that someone else is also good at their expertise in the energy sector, and understanding what things you don't know to then extract the right information from that person, and vice versa, to collaborate and then be able to come to the solution to solve the problem that you've got in mind.
Cool. Ed, what your feelings? Obviously, I'm hoping that you think you can learn the energy sector as well as the software sector. But yeah, what are your thoughts on that? Do you need to have innate, I guess, domain knowledge of the sector that you're producing the software for, or does that really depend on other things?
Yeah, I would definitely agree with the comments on. I don't think you need to be an expert. I think you have to come into any role with a willingness to learn. And I think history, there's many examples of technologists coming into new spaces without a lot of knowledge of the existing space, and being able to disrupt and do things no one, experts, thought were not necessarily possible or wouldn't think to do. At the same time, I'm sure there's just as many examples of hubris of technologists going into industries thinking that they can immediately disrupt it without any knowledge as well. So I think humility, knowing what you don't know, willingness to learn from experts, but then challenge convention, I think, is the right sort of needle we want to thread with the work we're doing. Where are places we haven't explored because everyone said it wasn't possible? At the same time, how do we learn from the mistakes as quickly as we can? So I'm definitely a supporter of the learn and grow if you have the right intentions and humility.
And certainly, my thinking on it is, as a developer, is that you tend to burn your skills about every 5 years in terms of the actual technologies, but it's the patterns and principles that sort of emerge and come out, and those are the things that will actually hold you in good stead moving forward. I'm wondering if there are any sort of direct parallels there with sort of domain knowledge within industry as well. Habiba, what were your thoughts on that?
I mean, since I've been doing ultrasound for probably the past 5 years, I can see why there is that turnover where you started doing a technology and then you start moving towards the end of that 5-year period, and then you start to kind of move into a new section of technology. So before, I used to do a lot of power ultrasonics, using power ultrasonics to reduce fouling on structures, which can then improve the efficiency of that structure, for example. Whereas now I am working with ultrasonic sensors to optimize a facility by taking useful information, outputting that back to the user to then adjust their operation so that they can then improve their efficiency and then reduce their carbon footprint. So I do understand that every 5 years, potentially, that there is that shift in the technology in terms of what's current to what's now current and what's now in the past.
Yeah, I'd kind of build on that of like, you know, just technology in general is rapidly increasing year on year. So if it's not changing, like I'd say it's changing quicker than 5 years. I'd say 2 years, and you're seeing drastic change in the way people are working. And that's just the nature of what we work in. It evolves, and if you're not changing with it, you're left behind. And we've seen how sectors of the industry have been left behind, and they're kind of irrelevant at that point. You know, there are certain points of it where you learn from the past and certain processes that were happening in that phase, which you take through. So like the processes side of thing, everyone's agile now and all of that side of things. And also everyone's figured out what agile actually means for them, which is very different in every company that operate in an agile way. It's just a constant learning phase. And I think that's the big part of it. Like Ed was saying, like you've got to be ready to learn. I learn every day, and I'm not learning from just seniors. I'm not learning from just leadership. I'm learning from juniors because they're actually looking at technology in a different way than I have. And it's part of what we do, is take that on board.
I think it's certainly very beneficial to keep the brain sharp, particularly as some of us are getting old and grey now. Ed, what are your thoughts on sort of patterns and principle reuse over maybe specific technology aspects?
Yeah, I always reflect back on why they call it a computer science degree, not a programming degree, right? Like the languages will change, the technology will change, but the core principles of the underlying technology generally stay the same, right? And so having a generalist mindset and a willingness to go expand and become, you know, a generalist over multiple areas, I think is sort of a natural progression for most technologists. And so, yeah, I think it's ingrained in sort of how we're educated from the beginning, in contrast to other areas where you maybe become sort of an expert in something very narrow. I think, you know, the education is designed for this sort of breadth and sort of adaptability over time. So yeah, I would just echo everything that's been said before. I think certain places are moving slowly, some are moving quickly, even sub probably 1 year. But if I even reflect on at least the last 15 years of my career, starting with like on-premise software shipped every 3 years at Microsoft, and they called it RTM at the end, right? To release to manufacturing, where you go print a CD or a DVD, to re-architecting for the cloud. Everyone was still building native apps or desktop apps, movement to, you know, web as the primary client, mobile after that. And those have been, you know, that's over 15 years, basically, where every 3 years or faster, you're learning a completely new technology, a new interface, a new business model. And yeah, I think it's what keeps the job interesting. If it was the same thing over and over, you know, I think it would get old.
I think that probably leads nicely into the second question that we've queued up, which is what are we missing? Where can we, as a tech community, help the energy transition? And what has been left out? What have we missed? What are the things that aren't there now? Ed, I'm going to come to you first.
It's a good question. I'll be honest and say I don't necessarily have a super opinionated perspective on this yet. I think right now we're trying to just get a lot of the basics, which I think is maybe the right thing. Like just, I think to Michael's earlier comment, like modernizing our processes, just getting apps to be sort of native in the cloud, for example. And so getting the basics right, I think, is important. At the same time, you know, there probably are, I don't know what we're doing in like VR and AR and a bunch of things that are sort of, you know, the metaverse everyone's talking about. And so at least one of the nice things I've appreciated about at least the organization I sit in, BP, just as an example, we have a mix of, you know, folks like myself who are really focused on like nuts and bolts. How do we become a software company? Boring but important things like, do we have logging and telemetry for all of our services so we know they're up and available? It's not the coolest cutting edge stuff, but it's important to make sure what you're building is on a good foundation. At the same time, there's a digital sciences area within my boss's org that focuses on this cutting edge stuff, like 10 years out, how are we going to use quantum computing? They've been tracking that for years. And so I do think there's a good sort of balance there of 80% get the basics, but 20% be looking ahead. So you could do that. So, you know, robotics, I think, is in there, quantum computing, I'm sure there's others that are super interesting. But so I see bits and pieces of it. I just don't know how much we've really deployed it versus we're exploring the technology.
Brilliant. Mike?
Yeah, I mean, I think of this more in a, not even looking at technology as such, but the transition to clean energy as a people problem, like the education of a lot of people don't understand why they should be clean. And when they're spoken to about it, it can be currently quite in a harsh way, and that brings a very negative response and causes people to shut down and not necessarily take on opinions and, you know, really consume things. So the flip side of that, from an engineering perspective, from a technology perspective, how can we help people learn in an immersive way that, you know, really brings them along the process and helps evolve their understanding of why energy is the right way to go, why combustion isn't necessarily a good thing when we're looking at fossil fuels and stuff like that. Like, it's more about education, and technology is a key part of that to how we deliver it to people. And I'm not talking education from like a school university level. I'm talking just a general public education. You know, why would 60-year-old Bill, who lives with an oil boiler, want to change his mind to move to a heat pump? Like, you know, making him understand why it's a good thing. How little change can make a big difference if lots of people are doing little change, you know. Yeah, I think that's my main point.
Habiba?
Yeah. So I feel like one thing that's missing when it comes to this issue is that a lot of facilities are already set up. So then what happens is that you're trying to solve a problem by retrofitting around the current facility. So, which is fine, you can retrofit a solution to a problem, but then if you're able to find the solution to the problem, so say having like sensors, in my case, having them embedded into the system, making that whole system smart so that you can continuously get that data from the system from the beginning, improve its operational facility in terms of the inputs you put in to drive it, reduce the energy you need, and these kind of things. And then once you get that blueprint in place, you can then scale up that facility as a model into other places that you want to then reapply it into. So I think the main thing is just having that previous thought of how do you want to improve this facility before making it.
I think that's a stunningly good point in terms of we've done some internal research within Launchpad and Ventures and within BP, and it's somewhere around the cost of doing it at the time is around sort of 0.2%, and the cost of doing it outside of that and retrofitting back in just for a standard engineering project, let alone anything else, is something like 45% more cost to do that. So yeah, thinking about it before you actually turn the wheels in anger is definitely the thing. But obviously we're dealing with certainly the age of energy, which has been for the last 100 or 112 years or so. Do we also think maybe it's a transitional problem from the point of view of previously we've had coal and then oil, and before coal it was wood as an energy transitional thing, and these have been additional. We're now trying to move, I guess, energy into a space where we forget all of those previous fossil fuels. So it's almost a larger technology issue to be combating, because of the fact that we're not just incrementally adding now, we are doing the thing that I think all technologists fear, which is a big bang release effectively for that energy transition. Mike?
Yeah, sure. I think that part on the energy transition, again, there's certain education points that hit into that, right? Like we've actually recently, so we live in an area where there's no gas. So we are oil boilers. So we've recently moved to heat pump. And with that comes a completely different mindset of how things operate to be ran efficiently, which again, if they're not running efficiently, you're wasting energy. And there's a lot of that thinking when it comes to technology too, of like, how can technology help that process of switching people out of old mindsets with older fossil fuels? So can we create better systems that help them do that automatically? So for instance, a heat pump, the most efficient way to run a heat pump for hot water is to have it always on and trickle heating it back up, as opposed to the traditional way where people set it to run at night, heat the whole hot water storage up, because at the time with gas and oil, that's the most efficient way for them to actually heat that. So there's like loads of these little use cases where we can use technology instead to help automate that. So that people don't have to necessarily understand the true workings of it. It just does it and runs systems efficiently. And these things are how we use machine learning and like different AI experiences and feedback loops to make sure we're constantly evolving that theory and how we depend on it, because software is going to become stagnant and cause more problems. You know, like if something's running inefficiently, it will tend to run more inefficiently because there's a mechanical aspect to what you're doing and it degrades over time. So everything has to evolve, and if we have software in that manner where it can evolve, then we're instantly in a losing battle.
Cool. Does anybody else want to contribute to that, or should we move? It does provide a nice segue, I think, into the next question, which is sort of thoughts about AI and the energy industry and machine learning. How are we going to utilize? These are the buzzword bingo golden tickets, really. If you get AI or machine learning in any kind of technology pitch that you're doing, then frankly, you've already won the conference that you're at. So is there ways that AI and machine learning can help this transition, can help move that forward?
I think the most obvious one that comes to mind for me, right, is the just renewables and sort of the less predictability in the energy output, right? If you have a solar array, you have a wind farm, you know, the wind stops blowing, and so how do we sort of spread out that the energy dispersal into the grid, right, in a way that becomes predictable, right? And I think that's one of the biggest knocks against renewables, or at least it's a talking point on why they're dangerous and why we need to keep, you know, coal plants running in the U.S., for example. And so I think that's one of the greatest opportunities to sort of reduce the fear of, you know, a grid that's primarily or almost 100% renewable energy. And so you see a lot of investment, for example, Tesla, and sort of basically becoming their own energy operator with batteries, and basically finding the right moments, not only to make money, but also to sort of stabilize the grid. And so I think it's a very tangible place that will, I think, actually be an accelerator for renewable energy production.
Habiba, I'm hoping you've got some ideas about machine learning and AI.
Yeah, so we do use algorithms to look at our data with our sensors. So the good thing about AI is that you can take out human error from the problem itself, and then you can use AI to then predict patterns to then be the decision maker for you so that you can focus more on getting this data and then using that data to then extract useful information to then output back to the person that's then going to change the numbers, for example, or even close the loop and then have it automated in that way. There are downfalls with AI in the sense that you might use AI to over-engineer a problem, in the sense that you just apply AI just because you can, not because you actually need to save you time, save you money, and save you energy. So is this getting that balance right? Or when do you need to use AI, or when can you allow a human to take over for a certain aspect of a problem, for example?
Yeah, I agree on that. I think that a lot of people talk AI and don't necessarily understand that there has to be.
Oh,
No, your sound's gone, Mike. You've managed to go back on mute. Somehow.
yeah, I think you're muted.
I just muted.
AI taking over.
I've lost all my audio.
Your computer said no. You're not going to say.
I'll
that.
let you carry on.
Carry on, Mike. Sorry. No.
No,
Mike.
Can you?
that's back now.
You now, yes.
Cool. Sorry. I'm not sure where you got to yet, but I think there's a big thing around AI, especially in agency world, where people don't necessarily understand, that there needs to be feedback loops, so that AI can progress and use those algorithms to improve itself. There does always have to be some kind of human input at some point to make sure that it's actually trajectorying the right way, because AI can also cause problems, like Habiba was saying, and yeah, it's use it for the right reasons, like Habiba's already said, because without us doing that, we're just kind of using technology as a buzz, rather than for any relative output.
Do you think that is there a crossover point in AI and machine learning? There is a certain level of compute and energy that must be consumed in order to get the data and the information from sort of AI and machine learning, which is going to consume a certain amount of electricity as a result of that. Is there a crossover point where we're looking at the efficiencies that we are going to gain from that AI are not actually going to return on sort of the energy stuff? Effectively, we're generating zero benefit by doing it. Habiba?
I think it depends on how much is needed in that sector, and also how much value it adds by doing that process with AI and machine learning. So if you have a very big wind turbine and you need to do a very big processing of data from that wind turbine before you, say, paste it into its use case, but then, for example, you might do loads of processing of data that you've collected on a pen, for example. So this is down to balancing out that value of this asset is worth so much. So you want to put in that time, which can then result into energy to, say, drive a supercomputer to do this AI machine learning process to then output somebody to say, okay, this is safe to now get launched into its facility or into its operation. So I think that's the main thing, is just that value that you come from getting that data and then processing it.
Ed?
Yeah, it's actually an area when I was at Amazon, we talked quite a bit about just the energy usage of machine learning. And most machine learning scientists or teams that do ML sort of naively often pick like, hey, we're going to retrain this model on some cadence. And usually they look at it from the perspective of the compute cost, not necessarily the energy usage. And so there definitely is an education component here. I don't think most people, I think it's very hard, particularly if you're using something in the cloud, to get a true assessment of energy usage, like for the compute you're using. So I see that as an opportunity for cloud providers to start doing that, or for us to build approximations of what we think, a given instance per minute of compute time would roughly equate from like an energy usage perspective. But it's not something that I think enters into the conversation today, and it needs to, right? If you're ultimately retraining the same model for equivalent or small gains in accuracy that ultimately does not outweigh the cost of training that model, that's a problem. It's just like the common wisdom basically tells people to retrain when they maybe don't need to. So there's an education, there's a tooling gap there to help make that a real decision point. And then I just add on, I do think there is some interesting low-level research in, we in basically either chip design or in the ML frameworks to actually make them more efficient and use less energy as well once you have the baseline. So it's not hopefully it doesn't become a choice between don't train a model or train a model. It's, is there a cheaper way to train the model where I can actually make the cost balance out?
Right.
I kind of agree with everything that's been said here. There's not much else to add, I suppose. But it is a really good point that infrastructure-wise, we're kind of none the wiser of like the real impact that that's causing at this point. And that comes not necessarily just with, what we're talking about here, but technology in general, like people running web platforms. Realistically, they don't really know what's actually happening. And if they did, they'd probably, in some cases, make a difference. A lot of it comes down to cash, but if there are incentives that go along with that, running their infrastructure cheaper, then people will naturally make those progressions. And I think visibility is one of those key factors to all of this. If we're not giving people what they need to understand the energy impacts that they're doing, then they're never going to try and have that in their mindset when they're creating these things.
I think you were talking about chip design sort of progressing there and possibly the way that is done. We've seen very recently that there is a huge issue with chip shortages at the moment. I know from sort of personal anecdotal experience that I'm not getting my new laptop now until the end of January because it's been delayed again. So I'm still on this old steam-powered one at the moment. But we're seeing that impact on lots of sectors. We have a number of the companies within Launchpad who are now having to look at how they source their chips and what they do with their chips and whether they're having to redesign stuff, because the hardware aspects that they are finding, they're just finding that actually the lead times to get those chips are longer than essentially their cycles of development. Do you see that this is going to have a huge impact on energy transition? If these technologies, essentially, if the ready flow of silicon that has certainly enabled the last 25 years of revolution in technology, if that is not as available, and I guess have we hit peak silicon would be the big question. Ed, you look like you're about to go for one, so I'll come to you straight away.
That was just a deep inhale at the question. I don't know about peak silicon. I also don't want to overblow supply. Is it supply chain as much as actual production? It's I think really hard to disentangle some of those things right now. But obviously, geopolitical considerations and where there's rare earth minerals and how countries play along with each other obviously has made us all realize how fragile we all are to these disruptions. I've heard of car manufacturers basically going back to old speedometers because they don't have the chips to power the digital ones. I think ultimately scarcity breeds invention. And so I will be really curious to see what comes out of this. Are there innovations around getting more compute or different compute on the same amount of materials, for example? Are there places where we should explore alternate technologies, maybe go back to things that worked before and don't really need to be digital? So I think there'll be a lot of interesting results from this. I do think ultimately there will be a return probably to some amount of normal, but what changes come out and stay and become durable, I think will be really interesting to see. I can't predict what they are, but I think it's it's just a curious time in many different dimensions. I think we saw the same thing with COVID overall and innovation and how people communicate and collaborate.
Habiba.
Yep. So I feel like when it comes to the chip shortage, is this down to being able to kind of think of that it's not that it's a lack of resources, there's a lack of resourcefulness in the sense that, okay, you may have less chips now, but then how can you maximize the use of that single chip? So say, for example, with sensors, is that you might have one system or one chip per sensor to drive it, to take that data, whereas you could have one system which can run multiple cables out to multiple sensors to do the job for multiple sensors through just one system. So is this down to maximizing the use of the items that you have in stock and then make the most with that in that sense, so that you can, in some ways, produce energy and reduce the amount of power they're using by trying to bring everything into one system rather than having multiple systems to do the same thing?
Yeah, I think those are really great points. Like, I think scarcity does drive innovation. Like, so from that perspective, the industry may even increase in its innovation in the sector. The flip side of that is, with scarcity, generally prices hike up too. So the hands of which those chips actually get into are generally the wealthier people. So from an equality perspective, people who can have innovation aren't getting access. So there is a problem around that. And, you know, that is the flip side. That slows down how we're going to go because less people have access to it. And it's kind of reined in by the people of wealth. That's kind of had to be raised.
You can't all be gobbling up for the latest MacBooks and iPhones. Cool. We're going to have questions in around about 10 minutes or so. We've got about 15 minutes left. So this is a question that maybe none of the guests have seen yet because it's just come into my mind. But I think we are, as Ed may have alluded to in his background, coming up to a festive holiday period. One of those things that you're going to do as a technologist, as an engineer, data scientist, what are you going to do for Christmas from a technology point of view? Oh, a bonus cap. For Christmas to actually make it a more environmentally friendly, a greener, cleaner Christmas. Mike.
Put down my phone and enjoy time with my family. Yeah, I suppose a lot of us who are in technology, actually, vacation periods are a time where we try to actually put down the things that we use every day to, you know, actually soak up real life a bit more. It's a hard question, though. I've not really thought about it to any extent. I mean, from a personal perspective, at least we've made a transition personally as a family to move to like a cleaner way of heating our house. So there's that. We should have a hot house just by utilizing air and electricity. But you know, it's a hard one, and I think it's the biggest impact is just think about small wins. Don't think about, oh, I'm going to do this elaborate thing. But if you can turn off that light for an extra 10 minutes a day, hour, you know, it all adds up in a year. And I think that's probably where I'd maybe think of the micro gains that you can do individually. And if we're all starting to do those things, it will make a difference.
Habiba, have you thought about what you might do for over the festive period for either improving your energy consumption or being more environmentally friendly?
Yeah, so the first thing I've done was do a smart meter on my boiler. So now I can control my heating from an app, which then can track to see how much I'm using to actually optimize it in some way. So hopefully that goes well, savings and energy wise. Another thing is to not put lights on my tree this year. One is because the cats might attack it, and secondly, just to reduce that energy use.
And Ed, you are very festive in there. You've got the best background from a festive point of view of all of us, really, putting the rest of us to shame.
Yeah, after the last comment, I won't mention that we have 2 trees, both with lights on. I guess I'm covering for
you've got her tree.
Yeah, any of my fellow panelists who did not go with lights. Actually, I think the biggest, and I wouldn't say this was a conscious choice purely around energy usage, but we're not traveling. My family's not traveling this holiday season. We're just sort of staying where we are. I think part of that's obviously COVID safety, Omicron type considerations, but you know, there's an incredible amount of travel during the holidays. People get on flights, and I know seeing family is important to many people. It is to me as well. But that's probably one of the maybe most tangible ways, in addition to some of the other things mentioned, smart thermostats and putting things on timers so they're not on all the time. Keeping the house a little chillier and using blankets is also a good strategy as well.
Cool. I think largely I've actually cut down on, we've set a limit for the kids' presents. Usually we're quite a big present family here, which sadly, due to the way that kids' toys are made these ways, seems to mean a mountain of plastic and other things, as well as everything else. We've actually set a limit of 6 presents per child this year, so that there's they're only getting so much, and also there's sort of psychological backing there that says that actually that's not a bad way to sort of teach children about the value of things as well. So buying less is my environmental tip there. So we've got some questions now from the Q&A. So I'm just going to go from the top really, and try and break those out into individual questions. So the first one is, what are the pitfalls that businesses fall for when they're creating these strategies regarding software and products? I guess what are the white elephants for sort of the energy transition? Things that actually are more, I guess, playing lip service rather than doing.
I think that the biggest one is that people try to put out such a polished product that they end up spending far too much time actually developing that product, when they could actually, you know, make smaller releases, get something out in the world, actually learn from it quicker. You know, it's why processes have been created to, you know, release often, learn, and then actually, you know, A/B test and stuff like that. I think that's the biggest thing that any business falls at in the first place. And then in terms of what was the second part? What do I wish commercial teams knew? That is basically understand the end user of what you're creating better. Like, far too many people go with, I'm going to be the best at X, without fully understanding who's consuming X. Do the user research up front before you've even started thinking about code. I think, yeah, that's a big problem in the whole industry, is that people generally run to code first rather than understanding what they're actually trying to build for.
Good product definition is always really required in order for you to be able to just guarantee that you can deliver it, really. Ed?
Yeah, actually, I would have, the first thing I would have said is Michael's comment. I see a lot of, you know, here's the PowerPoint with the grand architecture and product that then, you know, takes years to deliver, and, you know, it's either too late or not the right thing, and we haven't learned enough. The other one I would just mention is striking a balance, you know, between safety and speed. So, you know, BP has a very safe, safety conscious culture, and I think that makes a lot of sense given where the companies come from. But you always have this tension in software of moving fast, and sort of the Facebook motto of like break things, right? And you want to apply that in the right places where it really does not have an impact to human life. But you know, if you sort of put a safety and governance blanket on everything, it will slow you down. So you have to apply the right methodology. You can't just slow everything down where it doesn't make sense, and you obviously can't just be risky. And so I think finding the right calibration and right mode of operation depending on the application. So something on a rig, human lives are involved, oil production, environment, definitely want to be safe, cautious, and complete due diligence. But consumer apps to help you transact at a electric charging station are a different, just a different scenario and different risk tolerance.
Habiba.
So I feel like after all the answers, there's not that much more I can add. But one thing I could also say is, when it comes to software products, is that how do you integrate it with everything else in that facility? So the software may not be compatible with what you're trying to use it for example. So I feel that with a lot of companies is that they focus on just one thing, so just making software, just doing algorithms. Whereas, say with what I'm doing now is that we do like a tech stack where you make a sensor, you make the electronics to drive the sensor, the algorithms, the data, and then how do you use that data to then close that loop. So I think one thing is just having a strategy where you can have the whole tech stack all in one rather than having one part of the stack, which then needs a lot more things to then make the actual product actually work in the end.
Consolidation as much as anything, I guess. So we've got another one in here. Michael, you've got a direct question here. So Michael talked about the general understanding about energy consumption and its impact. Do you think the public is aware enough?
I think that's an easy one. No. I think, I think if the public were aware, they'd be doing a hell of a lot more and kind of understand why there is such a big movement in climate change right now. They'd understand that a lot better if they were aware of just kind of the impacts we're having, and the devices we're on. The internet is a big cause of that too. All of these server farms, they're not cheap to run. And by cheap to run, I mean the energy that's powering them. It's quite shocking when you start to look into some of that detail of like what we're burning through. So everything we can do to make the public more aware, to me, feels like a bigger problem than anything else in this sector right now. For me, obviously I'm not on the ground in the energy sector, but that feels like the biggest issue to overcome, and then everything will follow. If people want clean energy, then naturally companies will change their mindsets towards clean energy, like we're starting to see with electric vehicles now. The big brands have realized, we've got to make a commitment to going EV, and that's purely driven from consumers. So make the consumers aware, and it will happen just naturally.
Yeah, Nietzsche Roddick famously said that big corporations fear the vigilante consumer. That's probably the basis of most of those transitions. Ed or Habiba, have you got anything you'd like to add to that?
Yeah, I would just add I thought Michael's comment was spot on, the trade-offs, and ultimately, I think renewable green energy, making more environmentally conscious decisions will come with some trade-off to someone. So for example, to use the compute, it is better to use serverless technologies like AWS Lambda or Azure Functions because it's elastic compute. You're not getting dedicated compute that could be underutilized. However, it's more expensive than just having your own EC2 or bare metal machine in many cases. And so our business is willing to pay more for their compute because it's more environmentally conscious to do so. Same thing, if anyone, I used to work for Amazon. If you get packages delivered, they have an option to get all of your packages delivered on one day of the week, and they ship everything to one place and send it to you in fewer number of boxes, fewer trips to your house. But that means you will not get your package tomorrow. And are you willing as a consumer to make that choice? I think often these are, you only see them in sort of a cost or a convenience, but knowing that the convenience is saving you X, Y, and Z, and carbon emissions, we don't get that visibility, and it's actually really hard to compute that at a granular enough level to feel accurate. So, I think it's on all of us to ask for that information, and then I think make better choices, and maybe be willing to trade off convenience or price do the right thing.
Habiba.
So I'd say one more thing just to add to that is there are options also to have renewable energy as your energy provider, for example. So I feel that the options are there. It's just down to wanting to make that choice as well. So just to follow on from both answers. So is this down to thinking, okay, even though I could save more money by using non-renewables, I could then save things more in the long run for, say, further generations by just making that little bit more investment. So I guess it's down to understanding that it's not about spending more money, but it's more about investing in the future of, say, your kids, for example. So I guess it's that kind of shift in the mindset that's needed.
I guess it's as much as something else, I guess, a PR issue in that we look at cost at the moment just as pounds, shillings, and pence. What does this raw material cost to dig out of the ground or to stick into a machine? Or how much computer are we going to use? How much electricity are we going to use within this? We probably also need to start factoring in cost as in true cost, as in the cost of the energy that you're going to use, much in the way that the airlines now have to do for airline tariffs and things like that. We've got, I think, we've got 3 minutes left, so we've got the final question up on here. Akhtar's just put something up in the chat, so we'll go to this question, then we'll try and answer yours at the end there, Akhtar. 10 years from now, what software or kind of digital tools, or even technologies, I guess, do you think we will actively be seen making us make the journey to net zero? Habiba.
I say technology-wise is to be going towards more wireless in terms of sensing, from my perspective at least, because having all these wires, for example, it takes a lot of money to make these wires, having them a certain length, doing cable management and stuff. So I'd say to improve a lot of technologies is to find ways to be more wireless, and also how to charge something that is wireless, because batteries are quite expensive to make, and also charging them is quite expensive to do as well. So it's just getting that balance of how do you optimize the wireless side of things.
Okay, thank you. Ed.
I watch Michael unmute himself every time to go answer, and then you pick someone else. So I think you're just messing with him at this point.
Oh, I've known him for a while, you know. That's fine. He'll forgive me.
I do think maybe to add on to Habiba's comment, the compute sitting at the edge versus centralized. I know there was a big AWS outage recently, and now everyone's freaking out about how much stuff is centralized and is at a single point of failure. But we are increasingly having these really powerful devices in our hands, in our homes, which becomes really hard to make those efficient, right? So we're utilizing that compute versus doing everything in the cloud. And so I think figuring out how we basically optimize where compute happens to potentially put more on edge devices, for example, and less in the cloud, I think is an interesting challenge. Because compute isn't this just generic, I send a job to compute 1 or 2 and the same thing happens. And so that balance between the edge, like if you look at a lot of, Amazon has these retail stores that do a lot of ML. A lot happens on the edge because it's super expensive bandwidth, energy to go send it to the cloud. And so how do we do that in more of our consumer lives, offload compute to our cars, phones, other devices, all the smart devices around us, I think is an interesting challenge.
Cool. And finally, Mike.
Yeah. I suppose from I love what you've both said there. And the only thing separate to that, I think, which has its challenges from an energy impact. But obviously with Web3 and where we're going with VR, it does feel like it's going to happen in some sense. And I think that will be a big part of the future, and it may stop the need for needless business journeys, for instance. A lot of airlines, the majority of their customers are business users throughout the year. And the more we can kind of have an impact on that, create less journeys is obviously going to have a massive impact on emissions and all of that side of things. So I feel like getting better at VR, Web3 as a whole, both from a consumption perspective of energy, to actually enable that, so that isn't causing a big impact from an energy perspective, but also that more immersive conference business call. I think if we can solve that problem, then there's going to be a lot less journeys having to be made around the world, and that'll have a massive impact.
Thanks, Mike. Akhtar had asked the question, and I think it's probably popped up on the screen there. It's directed at you, Ed. So do you think companies themselves, like Amazon, are doing enough to educate consumers?
No, I think that's the sort of short answer. The slightly longer answer is a lot of these problems are really challenging. So I used to work in search at Amazon, so like product search. And we always talked about, wouldn't it be great if you could filter products by their environmental impact to create or to ship it to you, right? So you can make these really educated decisions. And the reality is that data is just not available. When you get a product from a manufacturer, knowing how much energy went into producing it and shipping it to you, or even estimating what is the energy cost of shipping that product with a whole bunch of other products to different customers. So I think they can be doing more. I think there's a lot of science that needs to be done to be able to put the right information in front of people, either on a real-time basis that's accurate or estimated or approximated, so you can make better decisions. Just like when they started putting calorie information on menus in the US, so you can make better nutritional decisions, we sort of need the same thing, except it's just much harder in a dynamic economy to be able to do that accurately. But I do think all companies, including Amazon and others, should be pushing the boundary there, demanding this from their suppliers, and then be accountable themselves to provide it to their end customers.
Awesome. Habiba or Michael, have you got anything you'd like to add as sort of final comment?
Don't think so. Not from my perspective. I think Ed answered that pretty well.
Lovely. Then thank you, all three of you, for joining us today and for giving up your time for this conversation. I hope it's been educational for everybody that's been tuning in. And thank you all for joining us.